Hello data points. Today we are discussing about PEAM, parametric embodied agent memory through the constructive internalisation of experience in Minecraft. So this is a Minecraft game. So in this game what happen is we are like in natural environment, we are like playing and doing all of things. We buy the things and we can do the surveillance, we can make, we can do the house, we can ride all of these things like the natural life type. Okay, so in this paper what happen is, just like if you remember our previous research paper, we are discussing about in that research paper how the skills OPT is evolved. So in this skills OPT we are in this skills OPT we are discuss about that how this is helpful for us. Means how the skills.md file is automatically evolved through the trajectory track. So in here they are saying that we are why we are doing it manually, we should do in a real time update. So this is all about. So the skills.opt is saying that we why we are doing the research here normally we need to do ourselves. So but now we are discussing about with, but we are know about how to do it. Okay, so skills.md, so like this is why we do like the trajectory. So here we are through the trajectory we understood how it's grow and evolve. But we need to, one guy is give me the like, I don't know who that guy, nobody is watching. I okay, yeah, I'm happy. So thank you who is giving me the live. So we understood how the trajectory is evolved. So in this paper we see that how this is real time update. So in this paper we are discussing about simple drawings. So this is this is an experience loop. First of all, say explore means it creates some kind of experience for its own, because in our real case we have the own experience, but here we have created his own experience by buying, create, digging, all of things. Then what actually work and what not, what actually work and what's not, it define through it. Then after it correct and succeed, after know which is working, which is not working, then we are through the trajectory. So here in this case, we are checking about each step, but here in this case, in this paper they are telling about how this is evolved. So after that the slow tire deliberative LLM. So reasoning, then plan, then reflect, then verify happens. Then the fast trier. So this is fast means this is the slow memory type and this is the fast memory type, you can assume. So in the slow memory type we are storing that where we have the lot of water, where we can buy, which is the best path. Either we are choosing a horse, or either we are choosing a horse or we are choosing a bike. Similarly, I don't play this game, so I don't know much things about, but I also read another paper where they are telling about the sandbox game, similar to here, similar to this game. They are creating the actual environment, and in this way they are uh, creating how our mindset work and how, and this is we discuss about, this is the slow memory and this is the fast memory. So in this fast memory we have few points like 0 0.1, 0 0.2, 0 0.3, 0 0.4, we can assume like that. And when this happens, they, when this skills.md is success, then it's notice what are the benefit we got. After we benefit we got, it can show save on the trajectory. So this do some calculation, do some scoring, after that parametric prompts are update, and this is the agent change. This agent change how evolved after through this after after using this trajectory we are knowing that this is the best agent. So yeah, so let's understood the agentic memory framework in Minecraft that transform the agent memory from the interface of time interval into a parametric residence skills internalized through the experience. Here we are discussing about how the skills.md, which is the parametric skills that automatically updated with the real time interference time. So in this here they are using the mixture of experts of LoRa. So after I got this research paper, I also not read this until yet, or otherwise I will explain what happens on this case. Okay, so then it gives the PEAM, one synonym, one type of shortcut for this parametric embodied agent memory. Okay, so after that, current LLM based embedding agent are typically rely on the memory that is not parametric. So what is non-parametric? Non-parametric. So non-parametric is the distribute free, the statistic method you use when your data violates the parametric assumption. Means we already assume something. We already assume something. On this case, we are using this. Okay. So yeah, we what is this paper? The learning reusable skills. So we later looking at that paper as well. So yeah, now the current skill agent, and after repetitive attempt in the same craft chain, the policy may remain unchanged. Here also in this paper, the skills.opt for the Microsoft side, they also saying about same. Why we are using the static skills.md, we do the trajectory analysis, and we finally got this paper. Finally got this the best test specific skills. So here also we are using the two embodied agent on here. If we are looking at, we are using the two agent on here. First of all, we are using the chat gpt llm agent, and another is the queen agent for this. Okay, so in this fast agent, they are treated as a training a single rather than a converting a failure trajectory, only a textual guide for a later prompt. Okay, I'll leave it. I also don't understood few things, so that I just sharing my learnings what I learned through the research paper. So here we do the embedding of all of this incident what is going on in this year. After that we do the failure case and the success trajectory through like this, through the like this the gradient descent way. After that we found out some pipelines, means which pipeline this work. Like similarly, if this is one guy who go in this direction, but in this direction they fall the rejection, then it's go this direction and this got the success. Then they save this path, this they save this path so that they can reach again this path to decide where they go. Like similarly here they are selection, conditional extraction, scoring, and the consolidate. So in this case the input as the visual and the textual. So in this game we are taking the visual and the textual game on this. This is the method how we can giving the inputs. After that they are converting into embeddings, then the LoRa is happening. After the LoRa, it pre-categorize the LoRa, and they decide what action to do and what to execute. After they execute, they think about either they succeed or they or it fails. If they fails, then decide upon this case, this update all of this. So this is all about this paper. So yeah, thank you for looking at this, spending the times. Yeah, join.